Okay, so let's take a look at a couple of these net change definite integral problems. And we're going to just set it up, but we're going to actually do the evaluation all just using our graphing calculator. So after we do the setup, you can type it into the calculator to get to the answer. So the first one says you have 30 gallons of pollutant at a lake at time 0. If the number of gallons of the pollutant changes a rate of P prime, and the units are in there is going to be gallons per day, determine the amount of pollutant after 12 days. So again, you're starting with the rate, and I want to get to the total amount. So what we want to remember is when you take the antiderivative of a rate, your answer will get to your population or whatever y value you're talking about. And if you're not sure, you can look at your units. So if I take the antiderivative of P prime, so notice the units on P prime is going to be gallons per day. The units on dt are days. So notice the days will drop out, so all you're adding up is a bunch of gallons. And my time interval that I'm going to use 0 for the lower bound, and I want to know what happens after 12 days, so I want to use 12 for the upper bound. So I'm going to get rid of this for now. So let's think about how we evaluate this. So the antiderivative of P prime is P, and then we plug in the upper bound, and we subtract the lower bound. So this is just going to give you the net change in that pollutant from 0 to 12 days. But be careful what the question is asking. It wants to know what's your final amount of pollutant after 12 days. So it's asking for this value. So really, I need P of 0. I'm going to just move this over to the other side. This is what I'm looking for. Okay. And P of 0 was given. It told us that there were 30 gallons to start with. So this is 30. This you're going to just get from your calculator, and if you add them together, you should get 23.422 gallons. Okay. Let's get the next one. So from 1990 to 2004, the production of apples in a certain orchard was, and the equation is given as labeled as P of T, but notice the units are thousands of bushels per year. So it is giving you a rate. And 1990 is going to be our starting time. So when we do time, we never use the actual years. Whatever time you start with, you want to count that as 0. And then 2004 will count as a t equals 14. So I want the total number of bushels from the beginning of 1990 to 2014. So this is not asking for the final amount of bushels. It just wants to know in that time interval, how many did I have? So I would just be integrating this from 0 to 14. Just use your calculator and you should get 34,925 bushels. Okay. Let's get the next one. Water is being pumped from a storage tank. The flow of water from the tank is given by this equation. Look at your units. It is gallons per hour, so it is giving you a rate. And T is the number of hours since midnight. I want the total water consumption for 1 day. So in a 24-hour period. Notice it asks for 1 day, but the units here are given in hours. So in that interval of 1 day, that would be 0 to 24 hours. This is my rate. So again, do this if it helps you to see what's happening. This is gallons per hour. This is per hour. I want total gallons. So this is adding up all the gallons of water in that 24-hour time period. Use your calculator to do the integration, and this is what you should get. Okay, next one. It says a pie is removed from an oven, and after sitting for 10 minutes, it's at a temperature of 220 degrees. The pie cools at a rate of 3 natural log of x squared degrees Fahrenheit per minute. What is the expected temperature of the pie 15 minutes after it is removed? Okay, so let's think about what's happening. it was 220 degrees after 10 minutes. So I started with 220 degrees. The pie is cooling, so we need to subtract off the temperature from 10 minutes to 15 minutes after it was removed from the oven. So at 10 minutes, it was 220, but then I need to figure out how much it went down from 10 to 15 minutes. So I'm going to be subtracting off this. This is the equation for the rate at which the pie is cooling. So again, this is degrees Fahrenheit per minute. Units on the degrees is your time, which is minute. So you're taking 220 degrees and subtracting off the additional degrees it's going down by in that 5-minute interval. Use your calculator, and the pie is going to be at a temperature of 144.431 degrees. Okay, last one. It says, throughout the day, people are entering a craft fair at a rate of this equation. Look at your units always, people per hour. And they're exiting at a rate given by this, people per hour. So people are entering the fair and people are leaving the fair. If T is measured in hours since the fair opened, and there were 200 people at the fair at the end of the first hour, how many people should be at that fair 3 hours after it ended? So I want to know the final count of the people 3 hours later. So we started with 200. And then I'm going to be adding on from 1 to 3 hours how many people came in. So again, this is people per hour. This is hour. So you're adding on the number of people who entered, but then we have to subtract off the number of people who left. And this we can type into our calculator, and we should have 482 people at the end of the 3 hours.